medal, right? When you say athlete events of medal, you get all the data that is in the medal column, right? Are you familiar with Excel file spreadsheets?
Kind of.
Kind of. Okay. Yeah. So let if 1 second, let me see if I can open a spreadsheet. I'll open this data set as a spreadsheet, and then maybe we can see first how we are doing this as a spreadsheet. Just give me another minute and I'm almost done connecting on my laptop. So how about Shruti? Shruti, can you share your method? Like, what is your method?
Okay.
Okay, what is Shruti's method? pd.notNull. Okay. Nice. Okay, so two of them did two methods. Let me do another method so that I can summarize all the methods possible. I'll mute myself here as I log in there. Launch meeting. Okay, continue. Join.
Recording in progress.
Can you guys hear me? Okay, cool. So I just switched successfully. Okay, let's open. I'll open the spreadsheet first. That 120 years of Olympics. And disable notifications. Okay. Can you see the spreadsheet? Right. So now this column is showing us the name of each athlete, right? And if you scroll a little bit to the right, this shows whether that athlete got a medal or not. Okay. So in this spreadsheet, if you just look at the first 10 rows, how many of them got a medal? One, right? If we look at the first 38 rows, how many of them got a medal? Just two, right? So that's what the question is asking about. So you have to somehow figure out how to filter out or how to only identify the records where there is a medal not equal to NA, right? If you are doing this with a array, you would have written a for loop and said for each row in this array, if medal not equal to N, if row of medal not equal to NA, then count, right? That's what you would have done if you were doing a loop. But with this one, what you can do is a filter. I don't know if you have ever used spreadsheet this way, but you can use a filter and remove all the NAs. Now you are just left with medalists, right? Does this make sense? So this is the same thing you can do in Python, in pandas as well, right? The same thing that you could do with a spreadsheet, You can do in pandas as well. There are multiple ways in which you can filter this data. There was one thing that Darren was showing, which let me open my collab. Okay. Okay, so the first method is what Shruti showed, right? Like her, what Darren showed, pd.not_null, right? So import pandas as pd, and then I'll upload this file. So pd.read. Oh, it's taking a little too long. Sure, actually, you don't even have to say as PD. You can just do this. You can do as PDS. As long as you use this name later, you just have to recognize that it's this name. But it's super common to call pandas as PD. If you're using code from someone else, like especially if you're working with someone else, using same convention might help, that's all. Right, so we saw this data here. Right. Yes. That's not, that's fine, Samir, actually, yeah. So you guys did two methods. One is using not null on the column. The other is using not null method in pandas to filter, right? Both methods do exactly the same thing internally. It's just number of lines. So first, let's see what Samir did basically. So I have to return this data set. So athlete. So if I say athletes dot of medal dot not null, right? So first, let's see what this gives us. Athletes dot medal of not null. So what is this giving us?
Truth values.
Right, exactly. So it's telling you for each row, does this have a medal? Yes or no. So it's almost like this. So you go and add here if O2 equal to NA 0 else 1. So now if you see 0 is false, 1 is true, right? That's, I could have actually changed this to say equal to NA, then false, else true. So this is what this thing is doing. When you say not null, it's checking for each row, is this NA or not NA? And it returns trues for only these things which are true, which are not NA. Does that make sense? Now you can add up, because false represents a 0 and true represents 1. If you add this, you get all the medalists. So if I just do sum of this one, that gives me all the medalists. This is only working. This is working because false is 0 and true is 1, right? False is treated as 0 and true is treated as 1 for when it is converted to an integer. Does this make sense? Okay. The method that I kind of prefer is actually using filters inside this, which is putting this thing inside this one. The reason why I kind of prefer this method is because it will give you the exact same thing as the above one. But now this only returns the data set with 39,783. The reason why I slightly prefer this method is because it works with anything else other than not null also. So if I want to count how many gold medalists are there, I can just do this. Right. So not null is a special method that only works for some special situation. This filter method works pretty much for any given filter, right? So within this parenthesis, you can specify a filter and it returns true or false for each line. And when you put this inside the square brackets, the result is you only get the rows where this condition is true. Is that clear? Okay. So this is filter based method. So filter based method. Now Shruti did another one. And as you can see, these are all correct methods. There is nothing wrong with any of these methods. Right, Shruti, this was what you did, right? pt.notnull. And is this how you called it also? So let's see what this returns. This result returns almost the same as this, right? So I'll show you what each of these things return so that you feel more comfortable. So see, all of them start with false, 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 true, false, 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 true, right? And that's the same thing that this thing also does. Oh, actually, I should say. So in this case, I should say not equal to, and this is where it becomes a little bit difficult. Right, yeah, sure. So I don't think I can say this, but let's see. Yeah. So the problem is NA is not a value. So I should just say not null here. There is no easy way to do other than NA. If I want to put this inside this filter based method, I should do the same thing as that other one. I also think there is a is NA method. Let's see. Is NA. Yeah. So this is the opposite of this. If you want to check what are nulls, you can also check is NA. And is there is not NA? No. So not null is the equivalent for is not NA. So this is the primary idea with these filters, right? I just happen to prefer putting the filter inside this and then getting the final data set, but you can always do sum on this directly and that will work. The only time that doesn't work is if I ask you how many gold medalists are there, then this won't tell you how many gold medalists are there. So this is that question. Someone else had some other question on something else. So medalists versus athletes or something. So did you guys have any other questions on this one? Number 6, on an average, how many medals did an athlete win? Yeah, so how would you do that? Darren? Why is medals an athlete win total medal by unique athletes? Right. So let's see here. Shouldn't it? Right. Yeah, that's the problem, right? Like if you count as total athletes, then that's also an average. There is nothing wrong with that average. But look at this in this data set. My intention was maybe the question is a little bit ambiguously framed. Of the winners, right? If someone won one medal, he's a winner, right? Like he's an athlete who won a medal. Of the winners, how many medals did each winner win on an average? Right? So that's what my interpretation was. Maybe I wrote the question slightly wrong. That's all. Because if you divide by the total number of athletes, right, what you get is slightly a very small number comparatively, right? Because of all the, how many athletes are there total? So again, you can easily open this in Excel and look at it in Excel itself, a lot of these questions. So totally there are 135,571 athletes, right? You can just do this in Excel. You don't need to do with the other stuff. And then if I exclude all the NAs, there are 39,783 winners. Of these 39,783 winners, there aren't 39,783 unique athletes. As you can see here, Arvo, Osayan, Alkmonen won 2 medals in 1920 Summer Olympics. Right? So I want to count from this 39,000 or so athlete winners, how many of them, what is the average number of medals? How many total unique athletes are there? 135,571. How many total unique athletes are there here? Easiest way to do is, if this shows a count, this doesn't show a count nicely, but what you could do is something like this. See, Excel is very powerful as a data analytics tool itself. Too bad. Okay, let's undo this. I'll also undo the filter that I did, and I'll sort by this. Then I get everything in one order. Okay, so I go and exclude the ones that are NA. Actually, I'll filter this out and I'll delete all the NAs. Then we are left with only medalists. Right, so this is what we are internally doing visually anyways. When you are doing it false, because the program does it much faster than what I do, you're not seeing what's happening, that's all.
Also, how do I ditch all the repeat data?
Sorry, what's that, Jonathan?
How do I ditch the repeat data?
How do you ditch the repeat data? Oh, so yeah, we'll see that today. Yeah, let's see that. How do you do that programmatically? Right now, I'm showing how do you do that in Excel. Then let's see how do you do that through Python. Yeah, drop duplicates, right? You can drop duplicates.
Also, what's the collab link?
No collab link yet. I'll give once I start doing something new. And so, okay. So as you can see here, 28,252 unique athletes have won 39,000 medals. So 28,251 athletes have won a total of 39,783. So 39,783 medals won. That was won by 28,251 athletes. So on an average, winners are winning a lot more than one medal, or not a lot more, like maybe 1.5 medal roughly, right? So those who win more than once, quite frequently. Right? So that's just data analysis. Now, how do you do this here? So that's one of the things that I wanted to go over first. So I say athletes, right? Athletes of, you should go by ID. Whenever there is a name and ID, use ID, because it is possible that there are two exactly same named athletes who are actually different. I don't know if that's the case in this data set, but it is possible that can happen. So if there is a choice between an ID and a name, go with ID. That's just slightly safer. So you can do athletes, you can say drop underscore duplicates. Actually, you can get athletes of ID as so now this athlete IDs is just a one-dimension array. In this, you can drop duplicates. and in place equal to true. Now you can just see the shape of this thing, and that will tell you how many unique athletes are there. So there are 135,000 unique athletes. Now, if you want to only get the medalists, you can put a filter before this, right? Medal subset equal to medal, right. Yeah, you can definitely do all this. Would that work? Yeah, I'm sure it will work. Just let's see, because if you have already made it work, I'm sure it will work. So you're dropping NAs from this. Yeah, if you drop NA also, that would work. This will work as well. So we will say athletes of medal dot not null. So now this will give me winner IDs. So the first one was giving me athlete IDs. This one gives me winner IDs, right? So, and then from this, I can again drop duplicates. What this drop duplicates thing does is it will remove any duplicates. So if someone is repeated twice, it removes. Value string to return a slice of a data. Okay, so this is not a data frame. So this is a series, not on a data frame, but let's see, they do it still. $28,250. Okay, so it still did it. Yes. So that was our answer, right? 28,251. And total athletes were some 133,000. If you want to find out how many winners, you just, before you drop it, you can count it here itself. So there are multiple methods, but try to focus on the idea. Don't worry about the syntax. There are multiple methods to get the right answer. Just try to figure out one method and understand what that method does.
So what should I define athletes as?
What do you mean by what should I define? So,
Like what should athletes be defined as?
each unique ID is one athlete. If you want to just stick with one column, is that what you're asking, Jonathan?
Yeah, but what's the code to do that?
Oh, this is the code to do that. So athletes of ID dot unique. This will give you like how many. This will give you an array of all the unique athlete IDs also. So this will just give you an array of all the unique athletes. You can even do with name. There is nothing wrong with doing with name. So this will give you all the unique athlete names. And then you can calculate the length of this array. Because it's an array, you can calculate length. And that gives you. So this is where, let's see, with ID versus with name, do we get different answers? Yes, you get different answers. All this means is there are some athletes whose name is same. Right, exactly. You get different answers, and that's kind of expected, right? Because you should see in some instances, two people may be named the same, but they are from different countries. They probably participated in different Olympic games, like 50, 60 years apart. Yes, you should filter by ID. I think like that is better always. I think I said ID right here. Each athlete has a unique ID. There are no gaps in IDs. Right, so this is better. Use athlete ID unique values as your athletes, right, based on ID. Okay, so that's the first question. So what about the second one? Any questions on the second one? On the last one. Okay, of the athletes younger than 15, of the athletes younger than 15 years old, sorry for the wrong phrasing, or older than 50 who won medals, okay, how many medals were awarded to an athlete on an average? It's kind of like this question here, but I didn't know how to filter a data frame based on 2 or more conditions. Okay, got it. Okay. So that's again like the same reason why I like this style more, right? So if I want to filter, first of all, how do you find out how many athletes are less than 15 years old in this data set? Oh, iter rows. Yeah, please avoid loop-based solutions as long, yeah, sorry, younger than 15 years, not older than 15 years, younger than 15. So please avoid loop-based solutions. You can do all of them with this, right? So if I say athletes of age,
When I try to use acid, it's giving me a syntax error.
oh, you have to name the data frame that way, Jonathan. Like I named my data frame athletes. You might have named it athletes underscore countries or something.
Okay,
Like
can you put that in chat?
okay, wait, let me share. I'll share my collab session, but you probably still have to add. Oops, what happened? Yes, but you have to probably add this data set yourself. I don't know if you have it, but so this one, okay, yeah, Jonathan method filtered by medal and age. Very nice. Right. So this is the first attempt, right? Like now you can filter all athletes less than 15 years old. How do you also filter athletes greater than 50 years old? Can someone figure out like how do you get athletes greater than 50 years age? Right, exactly. So very straightforward. Now, how do you combine these two things together? And exactly. So this gets you less than 15 years. So I'm putting a parenthesis next to this just so that it's clear. And you put an and put this one around. Oh, did I? I think I might have dropped somewhere. Let's. So I did something wrong. Let me see what I did wrong. Okay, this is giving me, oh, not and, or, right? You want or, you don't want and because, right, yeah, so sorry. Because there will be no one whose age is exactly 15 and exactly 50 at the same time, right? So these are all the athletes who won, I mean, who participated, who are less than 15 and more than 50. It would actually be very interesting to see, was there somebody who participated before their 15th birthday and also participated after their 50th birthday? Right? That would be surprising. Someone participates in Olympics for like 35 years or more. Would that be interesting to you guys also? Do you think there would be any athlete like that who participated once before they were 15 years old and once after they are 50 years old? Let's see if there are any athletes like that. So young athletes, and we'll say old athletes. What do you guys think? Will there be anyone like that? Any guesses? No, okay. Let's see. So you can merge this data set with old athletes data set. And how is inner? I'll explain what these mean just in a bit. On ID. Yeah, let's see. Okay, as you expected, no one is there. I'll go over what this merge does. I wanted to go over that in the homework itself, but somehow didn't find time. But let's see if we play around with this. Does there exist a limit where maybe 2040, if we try 2040, was there anyone who participated before their 20th birthday and 40th birthday? Let's see if we get any common stuff. Yes, right. So 2040 is working out smoothly, right? So he has been participating in Olympics for too long. It looks like he first participated in 1948. No, not this guy. Participated in 1980 Olympics when he was 15 years old, right? And participated again in 1980. No, this is weird. Oh, in 1984, participated when he was 19 years old. Did he win a medal in shooting? So in 1984, won a medal in shooting and kept participating till he was 51 years old. Oh, what went wrong was I said less than 15 and not less than or equal to 15 previously. So let's see, less than or equal to 50, greater than or equal to 15 and greater than or equal to 50. So there is exactly one athlete, Francisco Boza Dibos, who participated in 1980 Summer Olympics in Peru, no, from Peru, in 1980 Summer Olympics, and kept participating till 2016 Rio Olympics. Right, let's Google this guy. He has competed in 8 Olympic Games from 1980 to 2004. Oh, he also, as of 2010, no other Peruvian had appeared at even 6 Olympics. Boza qualified for the 2016 Olympics and was the Peruvian flag bearer. So he participated continuously for 24 years and then took a break for 12 years and then came back and participated again. It's a very unusual kind of story. But let's check with 2040. There are 471 records. Doesn't mean there are 471 rows. If you want to count how many unique athletes are there in this 471, how can I count? I'm hoping you guys are trying these out on your computers also. How many unique athletes are there? How would I count? Okay, dot unique, cool. So this tells me something, if I can get the length of this. So there are 89 athletes who participated in Olympics before they were 20 years old for the first time. And then again after they were, and were still participating in Olympics after their 40th birthday. Is there a difference between, n unique gives you the number, unique gives you the array. So if that's the question, so Unique is giving me an array. See, if you see this, unique gives me an array. N unique gives me the number. Is the difference clear? So if I don't have to do length of unique like this. Okay, so this is very surprising, right? Like 89 athletes. Did you believe that someone could be participating in Olympics for a 20-year duration, like 6 Olympics almost, right? Exactly. It's the length of the unique array, except it's easier. Yeah. Because it's common, right? Why would you do unique other than, I mean, you could do unique for a number of reasons, but one of the common reasons why people try to find out unique values is to find out how many of them are there. So that's why they came up with two methods. One to get you the unique values, two to tell you how many unique values are there. So this is good. Any other things you'd like to see? So in this question, like, so we were talking about this question. So we want to first consider only medalists, right? So amongst medalists. So how do you consider only medalists? How can I filter this data set to get only the medalists? Now I'll not do it myself. Someone has to give me the answer. How can I find out only the medalists amongst the athletes? Okay, that's one way. We'll hold on to this. Any other method? How can I get medalists amongst athletes? Yes, that's why I said I'll hold on to that method. Subset of medal, da, da, da. Yeah, can you give the full code? Oh, so, okay. Without the drop in A. Anyone knows how to do it without the drop in A?
Why is it giving me weird numbers?
I don't know what you're trying, Jonathan, but let's first finish this one, and then you can share screen and we can see why you are getting weird numbers. So how can we find out only the medalists? Anyone? Shruti or Darren? Oh, Darren already gave. Sorry, Shruti, Anmol. I'm just randomly calling out names. Yeah, sure. Yeah. I mean, not null. Yeah, right. So whoever is a winner are the ones who have not null, right? So medal. Since she already gave half the answer, so this one will give me all the medalists, right? Right. So would not equal to NA, and let's see, Anmol give a new answer compared to all the answers we have evaluated so far. So let's see if this gives the answer. So see here, it's gave you NAN again, right? The reason is when it says NAN here, NAN is not a string, right? Oh, wow, good. Right. So NAN is not a string, but let's see if I try this. NAN is not a value. You can check for values. I think it's just called np dot null. Let's see, np dot null, np dot nan. Let's check for that. Oh, I didn't import. All lowercase, I think. Okay. No, doesn't look like that also works. So not equal to doesn't work at all, right? Yeah, you can do that. Tanvi, you can do that, but we are trying to avoid loops, Tanvi, because sometimes loops are super slow, right? So let me take your loop and see what happens. How long does it take? So let's check here. Oops.
Can I check my code because something's going on?
Yes, in a bit. String indices must be integers. Oh, okay. So your athlete is. So this is like a row. First of all, you can't do this because you have to do iter rows, right? If you do iter rows, that's fine. This thing returns two things. It returns index and data. Now you can try this probably. So see, it's taking some time, right? Wow, this is too much time even for this loop. Oh, and it took over 20 minutes to run. Yeah, that's the problem. Yeah, okay. So it finished. It finished in like maybe 30, 40 seconds, right? Like I started. Let's see. It's showing you here how long it's executing. So it's showing us it's 14 seconds since I started running it. 16, 17, 18, 19, 20, 21, 22, 23, 24. So it took 23 seconds to do this, right? To find out the medalists. But if I do this, it took 0 seconds, right? And it even included the time it did to print this thing, right? If I didn't print this thing, it would have been even faster. So if I did this, see the difference between loop-based methods versus these are set-based methods. If you want to think of them, these are more like set-based methods. So they are incredibly fast. Does that make sense, Tanvi? So we are trying to avoid. I know we have tried so far. It's very hard till last session, or like till 2-3 sessions ago, to get you very familiar with loops. But now those are no longer helpful. These are much faster. So this will tell you how many athletes are medalists, right? So I say medalists. So now I have a data frame with medalists. Now I want to select only the medalists whose age is less than 15 or less than 50, or sorry, greater than 50. And OR is like this, one single vertical bar or type symbol is OR. Did I say less than, equal to, or less than? I didn't say anything clearly. Too bad. Yeah, I should have been precise in my definition, right? I should have said less than or equal to or less than. So, okay. So if you guys try different things and get different answers, that's okay.
Can I check my code?
Yes, Jonathan, almost done with my code. So 302 very young or very old athletes won medals, right? So amongst medalists, there are either 302 of them who are either very young or very old. But how many of these are unique ones? So if I check this, dot n unique, so there are 220 very young or very old, and very is a very or young. Let's just drop very is a very strong term. Young or old athletes who won medals. How many medals did they win? If I use the AND operator, then It means like someone has to be both 15 years old and 50 years old at the same time. Use the and. Oh, okay. You're saying like for and it's ampersand, right? Right. Yeah. Yeah. So or is like this, and is like this ampersand symbol. So if I get this shape, there are 302. They won 302 medals. So on an average, 302 divided by 220. So 1.37 medals. So even amongst very young or very old athletes, those who win end up winning more than one medal good number of times. Okay, let's see what both at 15 and at 50. We already saw it, there were no one. So this will give you 0. Right. So we already saw this one. This is giving us 0, but yeah, with or you get either this or that. With and you get someone who won, but you will not get anything here, Satvik. It's not possible to ever get a data like this, right? So let's look at this. We know that there are some athletes who are less than who participated when they were less than or equal to 15 years old and who participated after 50 years old, right? We already saw one athlete's name. So let's check that one. Satvik brings up a good consideration to have, or age, sorry, not ID. So if I put an and here, so we put less than or equal to, we know there is one such athlete for sure. And if I change this to greater than or equal to 50, it gives me 2,203. Oh, sorry. So it's giving me basically all the 15-year-olds who participated. So it gives me 0 rows, even though we know one athlete exists. The reason is it is evaluating this condition on each row, right? So this condition, if it is true for someone, so let me show here. So in Excel, if I go to this row and let's say find somebody who is less than 15, yes, let me tell you how the filters are working. So the way the filters work are they work by row. So first it goes to this row. Is this athlete's age less than 15? Is this age, athlete's age less than 15? No. So it gives me a false. And then it checks the other condition. Is this athlete's age greater than 50? It gives me one more false, right? So then it does false and false. So that's false totally, right? Is it ever possible that a number is both less than or equal to 15 and greater than or equal to 50? Can you ever get a number that is right? So that's why this will never work. This will never give, because these two conditions are exclusive of each other. So these are mutually exclusive conditions. You can either be less than 15, a number can either be less than or equal to 15, or a number can be greater than or equal to 50, but not both at the same time. That's why this and doesn't give us anything. Not because it's the wrong thing to do and, but just because in one row with one value, this never works out. So now moving on. Hopefully these filters are clear. Just to see how clear these filters are, can someone tell me some questions so that I can check how well you understood these things? Okay, so I'll ask a couple of questions maybe. Can you find out how many athletes participated in Summer Olympics alone? This data set includes athletes who participated in both Summer Olympics and Winter Olympics. So see, season summer, season winter. So I would like to know how many athletes participated only in Summer Olympics. So two things actually. How many Summer Olympics events are in the data frame. How do you get 220 young or old athletes? I tried and I got it, and I got 3015. Here you got participants, Darren. You didn't get medalists, right? If I change the same data sets to athletes, I get 3015. That's why some of these questions I'll try to be more precise. So this is a very long sentence. Of the athletes younger than 15 or older than 50 who won medals, right? So that's the condition, right? You have to only check the medalists. Length of athletes of season. Okay, Satvik, what did you get that? If you try length of athletes of season. You got 1.0 exactly, then you probably answer to that is 1.37 something, 1.3727, 37272727. Oh, that's a good non-terminating number. Right, so if you're getting exactly one, then you're probably calculating the same thing in numerator and denominator. So this is how you would go about it, just steps, right? First, get the list of all medalists, right? From those, select all the medalists who are less than 15 or less than or more than 50. That will give you the total number of young or old medalists. Then with the same filter in place, count the number of unique IDs. So count the number of unique IDs. This will tell you how many unique athletes have. So there are 302 medalists who are, 220 medalists who are very young or very old. They won 302 medals. Is that clear, Shruti? Okay. Yeah, some of this, again, I understand it might look a little bit confusing. And this is where like data analytics are, that's where we are going towards. You have to think of what does the data mean, right? More than what is the code doing, you have to really try to understand what is this giving to me, right? When you run some code, okay, length of, that's good. Okay, so Satvik has a good filter based answer. Satvik, please check if that's giving you the right answer, right? Basically, so you can check yourself, right? Oh, you don't have the data set? You can download from this link. Because if you don't try, you'll not, oops, not this one. So go to this website.
Okay, take a look at my code. It's just giving
Yes.
me weird numbers.
Yes, Jonathan, let's take a look at your code. Can you share your screen, Jonathan? Okay, so where is the starting? You have to go all the way to the starting for me to understand. Okay, athletes. So can you run your first one? You didn't run your first one, it looks like, right?
Yeah, I'm using the wrong notebook. Let me just change it real quick.
No, you're not using wrong notebook. You're running from what I shared. So run it. That's okay. Run it. You just say run anyway. You can run. Go ahead and run it.
Okay, so essentially this is giving me weird numbers that aren't what you got.
I can't see anything. I see the same screen still. I see the untitled 18.ipynb. Do you have two monitors? If you have two, okay, yes. Okay, now scroll all the way to the top. Okay, did you run that? I see. So you must have a slightly different date. Okay. So you are getting 39,000, right? Same
Right.
thing as what I got.
Okay, I got this.
Yeah, you're getting the same numbers as what I got.
Yeah, somewhere instead of 1,135 is. Yeah, I think the problem might be fixed.
Okay. Yeah, most probably what happened is you somehow went and changed your athlete's data frame somewhere.
Yeah, probably that somehow.
You did something like drop. Yeah, see, that's where, yeah, you did it there, right? You did it. So what you did, no, that's athlete IDs. Sorry.
Oh, there we
Continue.
go. It's fixed.
Right, yeah.
Okay. Yeah, I think that's the end of the problem.
Okay, cool. Good. Glad it wasn't too hard, and all it needed me was for me to look and it solved itself. Okay, Shruti, you can share screen. Yeah, Shruti, go ahead, share your screen. Let's see what you're getting. Okay, so, okay. Athlete countries of not medal count drop duplicates. Oh, so you dropped the duplicates there itself, right? When you said medal attained players, you already dropped duplicates. So if someone got 2 medals, you just dropped them and you got it once.
Oh, okay.
That's it. So yeah, this is one of the things I would like to alert you guys to. Be very careful about what methods you run on which object, right? Because this is now a very, almost we are writing one line of code and it's giving us some answer, right? That's a big jump from where we were few sessions ago. So you can make a one line mistake and it will completely change your answer also. So you have to be very cautious about what's happening. So how many of them participated in Summer Olympics? What's the answer? How many of them participated in Summer Olympics? Pandas, read CSV, NOC regions, merge, thank you. Seasons, can unique. Okay, cool. Satvik did it. Okay, let's see. Let's run Satvik's code and I'll pause and I'll run his code and see. Okay, I don't have that NOC region, so I'll just drop that. I'll just say athlete events. Okay, good. I got some answer from Satvik's code. So we now have one answer. Are there any other answers? So Satvik got this as the answer. Anyone else? Any other answer? Darren, Shruti, Tanvi, or a lot of other people. Aditya? What is the question? How many athletes participated in Summer Olympics? And how many of them participated in Winter Olympics? Not athletes, like how many total events did they participate in together? Like, so how many rows in the data set are for Summer Olympics and how many are for Winter Olympics? Because this data set kind of represents athlete events. One athlete participating in one event in one Olympics. So it kind of represents athlete events. So how many athletes events correspond to Summer Olympics? How many athlete events correspond to Winter Olympics? So one answer is 116,000. Are there any other answers? So Satvik, your answer is how many unique athletes? Let's say my question is kind of how many athlete events are there? So how many athletes events correspond to Summer Olympics? Which is fine. All you need to do is one small change in your code, just one small change. Okay, we can't proceed much further unless you actually, some of you contribute. So I'll go in order of what names I'm seeing. So Aditya, Jain. Sure, yes, Satvik, your code, that's what it's doing. So how many athlete events in the data set are from Summer Olympics? That's all of them, I think, right? Like 271,000 is all the Olympics, both summer and winter. $116,776 is the number of unique athletes. So one reason why I even suspected this answer was wrong, 116,776, is just compare these two numbers. If out of 271,000, if 116,000 participate in Summer Olympics, that means 155,000 participated in Winter Olympics, right? Does that seem correct that 116,000 participate in Summer Olympics and 155,000 participate in Winter Olympics? Does this number seem right? This is the number of Summer Olympics participants, and this is the number of Winter Olympics participants. Right, so this was why I thought this couldn't be right. And this is another thing with a lot of this data science, you have to make sense of the numbers, right? If your code gives you some answer, you should kind of try to see, does this make sense? Okay, so how would we go about this? We can try with a filter, season equal to summer. Okay, so now you got a more reasonable looking number. So Satvik got a slightly different number this time, 222,000, and the difference is about 50,000. Okay, let's see. So now I'm also getting the same as Satvik's answer. Perfect. Darren also did the same thing exactly as what I did. If anyone else has any other method, please feel free to share your method. There is nothing wrong with the methods. Perfect. Okay. So this is the filter based method. Now, what about Winter Olympics? How many of them participated in Winter Olympics? You just change this to winter, right? Summer to winter, 48,564. Now, how do you know if this is correct? If these numbers are correct? How can you check if these numbers are at a minimum correct? Good. So they would be correct if the total is equal to summer plus winter, right? At least one check. So this is true. So this is kind of correct, right? Does this make sense? So with any of these data analytics based things, you better figure out how to check your answer also, right? I don't know if you're if in school when you do like linear algebra or quadratic equations, one of the things that hopefully your instructors might have told you or your teachers might have told you is check your answer, right? Just because you solved and got an answer doesn't mean it's the right answer. You have to check your answer, right? That's the same thing that applies here also. You have to check your answer. And sometimes you need to find out how to check your answer, right? So one thing that I think you can easily do with these things, didn't do so easily. Maybe another thing we can try is, so there are some very interesting methods, right? Like, so certain interesting methods that are there on the data frame. This is one such method called describe. It actually describes a lot of statistics for all integer columns or Boolean columns. So if you see IDs, right? ID is an integer column in our data set. It is telling me that there are a total of 271,116 IDs. And the maximum value is 135,571. Minimum value is 1. This is the mean of IDs. It doesn't make sense to take mean of IDs, but it just calculates because it doesn't know what it means. The same way with age. There are 261,642 records in our data with an age. That means there are some athletes whose age was not known as of the time they were competing in the games. Same way, there are some records in our data where height was not known, where weight was not known, right? So this kind of tells you, these are how many rows in your table, because IDs are always not null in our table. These are how many rows in our table. This is how many rows that have an age. So some rows don't have an age value. So how do you find out rows that don't have an age in them? You can say is an A and then gate. So these are all the athletes for whom we did not know the age, right? So we don't know what this guy's age is as of 1948 Summer Olympics. We don't know what this guy's age is. Does it make sense to you that we don't know their age? When I print something like this, print athlete of event, it doesn't give the answer. What is the proper way? Actually, the proper way to print is without the print. So the proper way, like if I want to know, I didn't print here, right? I just selected this, or I just ran this, and it prints some results. If you want to print all the rows, that's a different story. Do you want to print all the rows? Right. So if you just want to see sample rows, this is good enough. You don't print anymore. Right. So two things that you learned a lot in previous rounds are used less with these within pandas. You can still use prints and loops. I'm not saying don't use ever, but use less than what you used to use, where you don't need to call print. It's not collab that's actually doing it. It's the use case, right? Like when people are trying to troubleshoot these, it's very common to look at data. So that's why when you just run this part of the command, most editors, not just Collab, I think even other editors tend to show you this because it's a convenient way of debugging things. So these editors are just making it convenient for you. It's not that can't do or shouldn't do. So this thing returns a data frame, right? When I run this, it returns a data frame. It's still not working for me. Can you share screen, Shruti? Oh, okay, I stopped sharing. You can try now. Okay, so athletes, okay, dot drop duplicates of subset events. Oh, now this is a series actually. So if you are selecting just one column, it's a series. If you want to make this a data frame, you probably have to cast it as a data frame, like pd.data frame of all of this. Do something like pd.data frame of this whole thing. I think you have to put a parenthesis, right? Did you put a parenthesis? You also need an opening parenthesis, I think. That could work actually. Whatever you're doing till there could work. Right. So now you got a data frame, but this data frame has more than event because you didn't select just event, right? If you want to just select event, you have to just select that one thing. Yeah, again, it becomes a series. If you do outside of that, you have to almost do it inside of that one. Yeah, there do event and then close the bracket. Right. So now this is a data frame. Previously, you were getting a series. Again, don't worry too much about, oh, if you want to add, what are you trying to do actually? Maybe I should have asked that first.
Find unique events for summer, like
Sorry, what's that? Find?
unique events for summer, like the summer season.
Oh, I see. Okay. Yeah, so that one, you probably don't need to do so many things after that. Yeah, I think, yeah, that's good. Yeah, this is good enough. Yeah, you got all the unique events. How many events did you get? 651. Wow. There are a lot of events. Okay. So in the next 10 minutes, we'll look at like two. Let me see. So I wanted to go over a few things. First thing is, let me write down what I want to go over in the rest of the class. Missing values. So I wanted to go over how to find missing values and what to do about them, how to find and what to do. Right? Because missing values kind of give you wrong answers. The next thing I wanted to go over is this thing called group or group by. And finally, I wanted to go over merge. Did I want to go over anything else? Then, okay, let's cover duplicates also because we already spoke about it in a good shot. So I want to cover these four things in the next 1 hour, 10 minutes. Let's take a 10-minute break. And once we come back, I would like to cover these four things. How to identify missing values, how to identify duplicates and how to drop them, how to identify, how to group by something and how to merge data. And I'll explain what these represent and what these mean. So I'll just go over these four things. Let's take a 10-minute break. Be back at 11 o'clock or whatever in your time zone. something like drop NA still running in a loop? Yes, Samir, yes, it is running in a loop, but the loops are not run sequentially, right? So they have some parallelization potential. So I don't know exactly the inner workings of that, to be honest with you, but it has to run in a loop of some sort. But it can, one way you can think of it is, it can use different kinds of data structures also to run that loop, right? So one way that drop duplicates could work is it's probably adding every element into a set, right? Instead of actually saying for and appending to something, it could be doing that. Let me see, how does drop duplicates work? Hmm. Oh, sorry, someone was chatting when I was searching for something. Sort problem still exists. Sorry, I'm not sure I understood what you said.
Yeah, the sort problem, right? Where you can't sort a whole list in one go. You have to do over multiple loops in order to sort a list.
Right.
So same thing that I figured
Yes,
with
yes,
drop
definitely.
duplicates.
Yes, definitely. Yeah. But one thing that they do is like different algorithms, right? Like for sort, there are multiple algorithms. You don't have to like loop through entire data set and do it like in one loop or two loops. There are algorithms where they could do slightly faster, but nothing can become in one pass, right? Like there is no algorithm that is one pass algorithm. It will
Yeah.
always be something slightly greater than one, but goal is to get it less than two, right? Just so you, it looks like you're somewhat familiar with the terms, but basically this is all how you measure complexity of a algorithm. Most algorithms that, I mean, any loop-based solution typically tends to have slightly higher number of executions needed to calculate the same answer than some other data structure based algorithm, like a graph based algorithm or a set based algorithm or a tree based algorithm. Those are slightly faster, not just because they are beating the loop, but because they are reducing some number of executions by using some clever data structure or something else. That's the idea.
Yeah, you're right. I think the idea is less about getting loops down to only one pass and maybe just decreasing CPU cycles.
Right, exactly. But that comes at a cost, right? Like it's not, you don't gain anything, you don't gain something without losing something. So it comes at some cost, right? Like if you are reducing number of loops, you're probably increasing amount of memory, right? That's why some of the algorithms can only run on supercomputers.
Okay.
Because you need both computational speed and computational and some sort of memory. So some algorithms are time-wise super efficient. Some of them are memory-wise super efficient. If you put both together, some of them have optimal efficiency in both, right? But if you give same weightage to both, sometimes you will probably end up with similar cost, right? If you spend one megabyte of RAM, if you consider that as $1, and if you have one execution and you consider that as $1, maybe you'll end up costing the same whether you use loop-based method or set-based method. But where are you putting your cost in is important, right? If you think your time is more valuable than your CPU RAM, then you should worry more about time-based complexity algorithms, like reduce your time complexity. Forget about your space complexity or your memory usage. That's the trade-off. But let me see if I can find the code for drop duplicates to see if yes, I can find it. Wow, group by itself has one whole folder in the base code. Okay, maybe I shouldn't attempt to do that in one day. Nope.
If you go to the search bar at the top, you just put it in and select this repository.
Right,
If you
and
put-
then drop
and then it'll show you.
duplicates. Reindex, test validate, miscellaneous, compare with spreadsheet. Done.
So even things within the source codes are calling drop duplicates. Okay.
No, there is more. What's new? What's new? Test join. There's a lot more.
Oh my God.
Okay, so let's do diff dot duplicates. If test drop duplicates. Okay, let's do. Wow.
There. Series.py at the top, it looks like.
Right, but this is all like overloaded on that series.
Ooh.
Oh, let's go to frame. Okay, so frame has some drop duplicates. So drop duplicates. Okay. Oops. That is fast. Okay. Okay. Right, so they are using an internal method called duplicated. And what does duplicated do? So start here. It's empty, no big deal. If not, create an ND array. Set is none. So looks like here is where they are doing this. Exist after all this. Okay, so difference. So they're comparing this as a set-based operation, but this is only to find out if some columns are not matching. Yeah, so see they're converting this self is more like a dictionary, it looks like here, and it says self dot items. This is kind of a loop, right? This is like list comprehension based kind of thing.
Yeah. Okay.
So it is internally still a loop.
Okay.
But just with good memory representation that it runs probably very fast.
Yeah.
So good question. So for it's time, let me just go get some water. I know it's 11 o'clock already. I'll just get some water and be back in a second. who were not there when I was talking to Samir. So Pandas is an open source library. You can go to GitHub Pandas dev and actually read what the actual code does or how it works if you are interested in that. This is an open source model. Most of these libraries with Python that are very popular are actually open source. So if you are interested, you can actually go ahead and read all about this, like how the internal implementation is. Just be warned that some of them are probably quite involved, the methods, or you may or may not understand certain things, but it would be a good exercise to go ahead and try to read how someone else made this library. And if you are interested, you can even contribute to this library, right? Like you can go ahead and add new methods or fix bugs. There are lots of issues. If you notice, there are 3.4K issues. Someone opened a bug 21 minutes ago, right? So if you're interested, you can actually start contributing to this. And that's actually a very interesting kind of exercise to contribute to open source code. It also sounds very cool if you tell somebody, hey, I'm one of the contributors to some very popular library. Okay, so let's go back to this one. Where was I? Describe, yeah. Can you see my screen?
Yeah.
Okay, cool. So I use this method called describe. All this does is it calculates some basic statistics, right? What's the number of records that are not NaN or that are not that have a value? What's the average of them? What's the standard deviation, minimum, maximum? This is the percentile number. I don't know if you are familiar with this, but all this means is amongst all the data that exists, 25% of the values in this column are less than 34.643. Actually, here it might make more sense. 25% of the athletes who participated in events were less than 21 years old. 50% of the athletes who participated were less than or equal to 24 years old. 75% of them are less than or equal to 28 years old. And all of them are less than 97 years old. So the oldest athlete is 97 years old. Someone participated in Olympics at the age of 97. Can you believe that? Can you guess what sport they might have participated in? Shooting. Wow. Archery. Okay, let's see. So how do you do that? Athletes of? So now how do you check that? So we want to know who is that 97-year-old and what sport that did he or she participate in. So you do this. His name is John Quincy Adams. Painting, yes. So art competition, yes, absolutely. He participated in sculpturing and statues. Why is that a sport? Yeah, it used to be something that they thought was interesting and then they removed it after. Yeah, it continued staying as an Olympic sport till almost 1945. EaseNA finds out if there is a NaN in the record here. EaseNA tells you if there is a null or not a number. Not null tells you if this is a number, right? So EaseNA and not null are like opposites. Tells you if a value is NaN, and not null tells you if a value is not NaN. Does that make sense? So there is some fun history behind this actually. Art competitions continued to stay in the Olympics till 1940s or so. And then just before World War II, Germany ended up winning most of the gold medals in art competitions. So yeah, it looks like just one Olympics after World War II, it continued. So I want to find out what are the unique years. So it started from 1912. 1936, as you all know, 1940 Olympics were cancelled. 1944 Olympics were also cancelled because of World War II. And 1916 Olympics were cancelled because of World War I. 20, 24, 28, 32, 36, and 48. And then after 48, they dropped it. So how did you calculate that, Ayush? Can you share screen, Ayush? Okay, age of athletes, file athletes, age, old athletes, names, file athletes, name. Can you print your age of athletes? Age of athletes, that array that you called age of athletes. Oh, you didn't put the closing parenthesis. Can you sort reverse equal to true? Sort with reverse equal to true? Yeah, in that sort itself, yeah, you can say reverse equal to true. Interesting. It looks like you have. Can you just take that second line that you have there, athlete age equal to whatever, the second line that you have there? Yeah, copy just that second line and put it in the next cell. Yeah. And you don't even have to do this athlete age equal to, just remove the athlete age equal to. Just let's run that part. Let's see what it displays. Okay, so now we got it here. Now here do dot max on this one, dot max. And it's with parentheses, I think. Right, so 97, interesting. So you didn't disturb any of the ages. Scroll up a little bit, let me see what's happening. For count in file athletes age. Interesting. Can you do one small thing? Take that for loop that you have for count in athletes age. Yeah, take that for loop. And instead of appending to an array, instead of appending to it, paste it in another cell. Print, instead of appending, print count. You don't have to up and down. No. Interesting. Yeah, you can stop this one. I think what might be happening is I exactly don't know what's wrong, but one thing that I'm thinking that might be happening or going on here is these are strings. They might be treated as strings instead of as integers. Can you check what's the data type of that? Type of count, or like just get one of them file. Yeah, type of count. It won't work outside the loop probably. Don't print, just don't print and just say print of type of count if you want to do. No, that won't do anything. You have to print. Yeah. Print of type of count. Yeah. Okay, they are being treated as floats. Not sure why you're not getting 97, but as you already saw, like there is data with 97, so I'm not really sure at all. We can look at it like at the end, but definitely remind me. I'm very curious to find out what's going on here as well. Okay, but in any case, so coming back, so this is how it describes some of the, only for integer columns, it doesn't describe this for all other columns. Out of the 15 columns that we had in our data, 5 were integer columns, so it described this. And it clearly says the oldest Olympics were in 1896 and the most recent one was in 2016. Can you make sense of what this means? Like minimum is 1896 and 25% of the data is before 1960. What does this mean? Can you tell me what you think it means? Why is only 25% of data less than 1960? So 64 years contributed to 25% of data. And then the next 56 years contributed to 75% of the data. Not popular, or what else can you think? Not a lot of events, World War, exactly. Anything else that you can think of? So why do you think in the first 64 years since Olympics started, only 25% of the events that happened in the first 64 years, and in the next 56 years, 75% of the events happened? So two answers: not popular, not a lot of events. Any other answers? Internet. Somehow internet caused more people to go to Olympics. Maybe, yeah, maybe. Wonderful. One more good explanation. There wasn't Winter Olympics. Very good explanation. Anything else? Any other reason you guys can think of? Why were there fewer athletes before 1960 than more athletes after 1960? Only got more facilities and events. Perfect. There is another very solid reason. Maybe some of you guys might not be able to think of it actually because you're not used to thinking of that kind of reasoning. Women weren't participating in Olympics initially as much as now. Yeah, money also increased. Countries became wealthy, but that's part of the reason why more countries are sending more people to Olympics. But women weren't participating in Olympics as much as men. In fact, initially when Olympics started, even though from the first Olympics, I think there have been women participating, but participation was far lower. So these are all different reasons why for the first 64 years of the Olympics, only 25% of the events that happened were in the first 64 years. Then you start seeing jumps, right? The next 25% happened in 18 years, between 1960 to 1988. And the next 25% happened in 14 years, and the next 25% happened in 14 years. So this kind of tells you that we are now kind of saturated, right? For every 14 years, there is 25% of the events that happen. So that means once it reached 50 percentile of events, the remaining number of events are evenly balanced. So since 1988 to 2016, there hasn't been too much growth in number of events or number of athletes participating. Winter Olympics already started. So there were no world wars, nothing that led to cancellation of Olympics. So that's even balance, kind of. You can't tell that for sure, but this is something that you can interpret or kind of infer from the data. It may not exactly be the same. There may be more events, slightly more events. There may be slightly fewer countries participating. As you probably know, in 1990, suddenly 15, 16 countries, actually almost 20 countries showed up in 1990 when Soviet Union disintegrated and became 20 countries or so. So suddenly 20 new countries showed up. So more athletes probably participated. So things like that could have contributed. And these are interesting trends that you might want to observe. We'll not do that in this class. We'll do that in next session, or maybe we'll start doing some of this in the homework this time and next time continue. But in this class, what I would like to focus is all these things that don't have data, right? How many athletes don't have data based on just looking at here, these two numbers? How many athletes don't have weight data? Can you tell by comparing these two numbers? $62,000, yeah. So roughly 62,000 athletes don't have weight information, right? Does that make sense how we arrived at that number? I just subtracted this number from this number. Why? Because this count tells me only the count of values that are, or number of rows that have a non-null value or not a nan value in this column. Now let's find out how to do this programmatically. You all know already how to find out how many athletes' weights are missing. Can you find out how many athletes are there whose weight is not a number? You can just do this and it'll give you. So this is how you can find out missing values. So when you do this, this returns a series with true or false. True when nan is in a row, false when row has a number or value. So this is what this returns. It returns a series. It doesn't return a number. It returns a series. Now what to do? So what can I do about the weight of athletes, right? I want to calculate, let's say, what is the average weight of all athletes participated. But right now it's only calculating the average weight based on the weights that are already there. Since 60,000 times I don't have a weight, right? It's not accurate. It's almost 23% of the times I don't have weight of athletes. So do you think that the average weight of athletes is correct now? If I remove 23% of the data, and if I calculate, is that a good average? Right. So now what should I do? If I want to do something better, what can I do? So let me change the question a little bit. If there are 30 students in your class, and I want to calculate what's the average score in math exam. If I don't know the scores of 4 students or 5 students from this exam, what can I do? So there are 30 students. I don't know the scores of 5 students, but I want to calculate the class average. So what are the methods to do that? Put average score of rest in their place. Yes. Put the scores of as the average so that the average won't change. That's one good method, right? So I first calculate the average of the remaining 25 students. And then say these other 5 students also got the same average. But that changes the average, right? It does not mean it doesn't change the average. It will change the average a little bit. In some cases, depending on how many, actually, no, sorry, I'm sorry. What a silly statement to make. It doesn't change the average. But is that the right way to think about it? Would it be a good answer? I know I got the answer for 30 students by adding averages, but is that a good answer? How can I improve the answer? Is there a better way? Is there a better way of calculating the average score than just substituting class average as the missing students average? What if I had previous test scores for all the students? Is there something you can do if I had all the previous test results? Let's say there were 20 previous tests and I knew what was the score. Substitute each student whose data is missing, I can substitute their average from the students from their previous tests, right? Is that better? It's a different test, so it won't be fair. Yes, good point. It won't be fair, right? So that's another objection. Yes, it's a different test. Maybe the students were better prepared this time. So one way to check this thing, right, is I'll calculate the average of the remaining 25 students from the last test and this test. Okay. If the averages are same, so the 25 students for whom I have data, if I calculate their average from previous tests and from this test, and if that average is similar, so let's say the average of the 25 students in this test is 70 and in the last test was 69, then I can say that the test was of equal difficulty, right? If the averages of the students for whom I have data are the same from previous test to this test, I can claim that the test was of equal difficulty, and then I can use their previous score as their current score. Would that be a good way to do? How about Anna? Because Anna was the one who objected. Anna, do you think that would be a way in which we can justify? Right? So that's one option. You can take either their previous averages or you can take the rest of the class average. Any other options you can think of? Anyone else? Yes. So Shruti, you're finding out that 62, oh, you are getting a slightly different number than me. Is that what you're saying? Okay. Let me see. Maybe I'll just, most likely one of us has changed our data set from the beginning to now. So I'm freshly loading my data set and I'll try again. Oh, okay. Yeah. Yeah. Most usually if you are getting different numbers, that's probably because you have altered your data frame from the time you loaded to now. So when you do E's and A, this tells you how many of them don't have a weight, right? These are the people for whom we don't have weight data. When you add this up, it tells you how many athletes participated in events when their weight was not known. Basically, like if you go for shooting or painting, it probably is not a common thing to measure their weight before they go, right? For some events, you don't care what the weight of the athlete is. So probably nobody bothered writing down. Or maybe before 1960, nobody was writing weights down accurately. Maybe, I don't know. I'm just saying, I don't know. So the two things that you guys said is one, substitute with the average value amongst calculated from the remaining data. Other method is substitute with average value calculated from past data. That's two methods. What else can we do? What if someone objects to both these things? What should I do? Okay, tell them to take the test, yeah, or give them 0, assign 0, right? Right, you can assign 0 also, right? They didn't take the test, so that means they didn't take the test. Doesn't mean there's nothing wrong with putting a 0. The other thing is ignore them and only report average of 25 students. If you guys think of any other method, let me know. So now let's see how to calculate average weight of athletes, basically. I think this is it. Let me see if this is it. Compare the average of 5 students with 25 students from past test. Yes, absolutely. Compare the average of the same missing records from past test versus missing record versus good records from past data. If they are same, then use past average or class average, right? So I'm calling this class average. This is past average. So you can either get the current data average, or you can get the past data average and do, or you can do substitute with zeros. So this is 0 filling. Or you can say drop data, right? So you can do these 4 things. This will give you confidence. By comparing, you'll get more confident on what you can do. Depending on how important this is to you, there are a lot of other methods you can try, and I'll not go into them. One of the things you could probably do is like group the students into categories, maybe, right? You could group the students and see where these 5 students, right, yes, exactly, a little less advanced than a KNN, is look at the past data of these students and see if you can group them into groups. Are there high performing students, low performing students, average performing students? Group them into 10 groups. Students who scored between 0 to 10, 10 to 20, 20 to 30, 30 to 40, and so on. And see which group do these 5 students fall into. Then group them again, group the current data also into 5 groups and calculate the averages of each groups and substitute the right average for the right student. I know I'm probably jumping too much here. Let me draw a diagram. So let's say there are 30 students in the class, right? So I'll just divide them into 4 groups. Students who got less than 25, who got less than 30, less than 50, between 25 to 50, 50 to 75, 75 to 100. So help me with putting numbers into these four quadrants. I want to put a total of 30 into these. So what number should I put between 0 to 25? So how many students in a class of 30 students do you think will get between 0 to 25? Seven.
Oh, God.
7. So Shruti is very skeptical about the class. Okay. So how many students do you think will get between 26 to 50? So on a test with 100 points, how many students do you think will score between 26 to 50 points? Three. Good. How many score between 51 to 75 points? 15. Wow, that's good. So you guys all know statistics. At least those of you who are talking about seem to know something about statistics. How many score? The remaining are 5. Only 5 students left. Okay, so I'll add that so that you don't give me some big number. So now this is from the past test, right? Like the past test that these students took. This is the distribution. Now I know that from the current test, I know there are 25 students who have taken the test. So let's say one of the top students didn't take the test. 2 of the average students didn't take the test, or 2 of the good students didn't take the test. 1 of the average students didn't take the test, and 1 of the poor students didn't take the test. Right? High performing, low performing, good and average performing. So like this. Now when I want to, in my new data set, let's have exactly like this, but I have 4, 6, 13 and 2. So now I'll calculate the average of these top 4 students. Right, I'll calculate the average of these top 4 students and then say the 5th student whose average I didn't know also scored the same. I can calculate the average of these bottom 6 students. I can say that the 7th student who didn't take the test also got the same as the bottom 6 students. So this is a more sophisticated method of how you can fill in the gaps, right? So group the past data into chunks and then group the current data into chunks, calculate averages, and then add up the remaining averages. Again, all this is doing is if I'm reporting to the state, right? If I'm the school principal and I'm trying to report to the state how well my students are doing, I don't want to report low average, right? I want to report as high of an average as possible. So I'm playing with these numbers really. That's all it is. I'm kind of manipulating the data in one sense, right? But I'm doing it in a very clever way so that nobody can blame me. I have some justification. And this is how financial crashes happen. This is how stock markets crash. This is why people become poor or rich. When you manipulate numbers to show things that are a different version of the reality. So just to see how you can do what is the remaining part. Okay, so I'm doing something wrong somewhere, obviously. So this is the mean of all the athletes. So I can substitute wherever there is a 0. So athletes weight substituted by mean. So how do I do that? First, I'll just say this dot, I think there is a replace. To replace, I think I just have to say this. Value is this one. I'm not 100% sure if this is the correct way to do, but let me check. No. Let me see, I forgot the syntax for this. Replace value with, replace NA with value pandas. Oh, I see. So I have to do it on the column, not on the data set. So I can say athletes of weight dot replace of np dot nan with this. I'll calculate this mean weight and put this here. So before I do this, I'll copy this data set. And then here I'll do this thing. Okay, and then I think I have to say in place equal to true for all the things like this. No? Is this replace? Yeah. If I don't do in place equal to true, it doesn't actually do anything. So now let's check if anybody has a null in this one. So now nobody has a null. Normal CDF to calculate normal distribution. Yeah, I'm sure there is something like that. So what did I do? I first calculated the mean weight of all the athletes, right? I'm copying this just because I want to preserve my original data. There is no reason to copy like this. And then I'm calling replace on this column and I'm saying replace this with the mean, right? And in place equal to true just means it will change this data, otherwise it won't change. So once I check after that, it's now 0. I mean, there are 0 athletes who have no weight information and the mean shouldn't have changed, right? So if I check what is the mean weight, it should be 70 point something. And now if I check the mean again, it's 70 point something, right? Does this make sense? So what I did, so I'm replacing null values or no values with some value, with a fixed value. I could have replaced this with a 0 also, but that will change it drastically, right? Like then it will change my mean drastically. So now it will look like all the athletes have gotten a little lighter. So the the average dropped from 70 pounds to 54 pounds. Was it 70 pounds or kgs? I don't know if it's pounds or kgs. Let's check once. Basketball player can have 80 kgs or 80 pounds. 80 pounds basketball player is kind of hard to find, right? So it looks like it's in kgs, not in pounds. Yeah, bobsleigh would have this. Skiing could have 59 kgs. Yeah, so this was in kgs. So our mean weight dropped from 70 kgs to 54 kgs. So by replacing with 0. So it's not as good of a method, but it doesn't matter. Like, depending on what it means to replace, you can replace with whatever you want. Now, I was talking about some other methods, right? Does it make sense to replace all athletes' weight with just all athletes' average, or should we consider by sport? Ideally, we should kind of consider by sport, right? Because it is okay to expect that one shooter will weigh the same as other shooter, but it is not okay to expect that one shooter will weigh the same as another weightlifter, right? Is that reasonable? So let's see. Before we go to this method, let's see. So one I substituted with the mean of the rest of the data, other I did zero substitution. The third is ignoring this. So how do I ignore this? So this pandas has also a good method for that. Athletes only with weight. Right? So this has a method called drop in A. I can say x equal to 0, which means rows. How many? So I need subset. The subset is weight. Now I've dropped the rows with no values. So let's confirm that. So it's 0. Are you guys able to follow what I did here? I dropped the rows with 0 or with no data. So this drop NA is another method where I can say drop the rows which have 0, no data in this column. So this is another thing you can do to account for missing values. So we just saw 3 methods. Can you guys try to apply the same methods on age and see if you are able to calculate, if you are able to do that? Same things basically. Axis equal to 0 means drop rows. So I'm saying drop rows where weight is not a number. So this translates to drop rows where weight is not a number. You can also drop columns where there is a value that is not a number. We don't want that. We don't want to drop columns that don't have a non-numeric value, because then a lot of columns will get dropped. So you try with age and see if you're able to calculate averages before, after. So tell me, like, substitute what is the average age? What is the average age once you substitute zeros for all the NAs? And what is the average age after you drop? Okay, Jonathan, you can share screen. So the question is this: what is the average age of athletes?
You stop sharing.
1 second, I'll type the questions. What is the average age of athletes after replacing NaN in age with the average above? What is the average age of athletes after replacing NaN with 15? Let's replace with just 15. What is the average age of athletes after ignoring NaN values? So 4 questions. Try this and give me answers, and then we'll try. Okay, I'll stop sharing. Jonathan, you can share now. I see. Is
Like, what's the issue? It's giving me a type error.
right. So can you scroll up? What is you in your? I think athlete is a series. Athlete is probably a series for you. Athletes, right? Your variable is called athletes, not athlete.
And this is also giving me issues.
Athletes. No, but what is IGHT? You should say is NA, right? Not IGHT. Is ISNA. Right. Run that.
Okay.
So the next one, athletes instead of athlete, right? It's not in the, yeah, there. You forgot one S. Yeah.
Okay, let's print the weight now.
You don't have to print, just type weight and it will print automatically. Just type the word weight and it will print it. Right.
Yeah, still shows NAN for the medals, but now there's no more.
That's a different problem, right? You only dropped where the weight is missing. You didn't drop where the medal is missing, right?
Yeah, so let's ask some code to drop the missing medals.
I know, but first try to start again from athletes. Try to start again from athletes and find out what's the average age of the athletes and drop the ones with missing age and solve those 4 things. Then we can see the rest. What is the average age of athletes? Did anyone get it already? What is the average age of athletes? Still doing it? Okay, no problem. Does anyone want to share screen as you are doing it? $25.55. Oh, really? That young? Nice. So what does that tell you? Most athletes who participate in Olympics are very young, right? That seems correct. Darren, are you reconsidering your answer? Why? You can talk.
Does that mean like taking NAN?
It's not taking or it is taking?
Is it taking?
No, it isn't taking. Yeah, it is doing it without the NAN. Right. So anyone else got an answer for the first one? What's the average age of all the athletes? How about Samir? Samir, do you have an answer? Or did you drop off?
Nah, my internet's being a little weird.
Okay.
I'm
Anyone
not able
else?
to. Collab is giving me issues.
Tanvi or Aditya, Akshita? Okay, Medha. Okay. So what, Medha, what are you doing actually? I just would like to know what are you doing or how are you trying to calculate average?
I'm trying to use the method that we used for weight, and it's yeah,
Can you share screen? Let's see. So
sure.
maybe we can. Right, it wouldn't work. Yeah, okay. So you're saying athletes. So you already found, right? When you said mean age, that mean age is the value. That's it.
Oh, so I just need to like print that and I'm fine.
Yeah, if you print mean age, you're done, right? You calculated the mean. Don't substitute. We just want first answer first. What is the mean age? Don't have to do everything in one shot.
Oh, okay.
So what is the mean age? If you print that, what do you get?
25.
Okay, 25. So someone else was saying something. Tanvi is trying to add the athlete's age, right? So Tanvi, what went wrong for you is, can you share screen, Tanvi? Right. Okay, you also use the mean. So when you tried previously, when you said athletes of age, that's, you're trying to like filter your data, right? It's not the same. If you want to calculate the mean, you should add up all the ages and divide by the number of athletes, right? That's the mean. So let's do that. I'll try to do that without using any method. I know obviously there is something called mean. So Tanvi, can you stop sharing? So I'll share and then let's verify if this is really the answer. So first I do athletes of age dot sum. So all the athletes put together weigh 6 million kgs. And then I know how many athletes are there. I get 24.66. But what I didn't consider is all the athletes who I didn't consider all the athletes whose age is not known. So if I ignore them, I'm getting 25 points. So if I only calculate the average of all the athletes whose age is known, then I get one answer. If I calculate it as the average of all the athletes, I get another answer, right? Which is expected, isn't it? So Darren, does this answer your question? Like, was it considering when it calculated that 24 whatever, it didn't include the NAs, right? So this is giving me the average age. Now, how about if I replace this? Does the average age change if I replace NANs with the average? No. Okay, so don't do that one. Then replace average with NANs with 15 and tell me what's the average age. Can you share screen, Shruti? I'll stop. Yeah. Can you share screen? Let's see what's happening. Shruti, can you share screen? Oh, can you share? Yeah. Okay. Okay. So what did you do? Oh, see what you did is, so, okay, who can help identify why Shruti is getting the same answer of none in both the cases? So you're printing some result, right, Shruti? You're not printing the mean in the second and third examples, right? You're printing the result of the operation replace. But wait a second. Once you replace, you will get none again, right? You can't calculate the mean of none. So after you replace, you put it on another line if you want. In another line, you calculate the average. Wow, really just that much drop? Slightly surprised, but yeah, makes sense. 620,000 out of 6.2 million, I mean 6.6 million. You're changing that by 620,000, so it's only like 10%. No, something seems odd. Wait, isn't. Oh, no, you don't have to do that. If when you do in place, no, you'll get an error. So when you do in place, it automatically replaces that thing in place. So you don't have to say equal to something, right? In the next line, you can say athlete age substituted by mean of age dot mean, right? In another minute or so, yeah. But hang on for a few minutes because I wanted to discuss about the homework so that I'll give the same thing as homework. Right. So Darren got a second average. Let me see, that average somehow looks too high for me, but he may have gotten the right average. $25.18. Looks like it is the right answer. Okay, so oops, sorry, didn't mean to stop sharing. Okay, now for homework part, since we only covered previous homework this time, we didn't cover that much. Are you guys okay to do like reading on this drop duplicates? How to handle duplicates? Are you okay if I give you some links, can you read up and then work on homework that involves, okay? And how about group by? If I give you some reading for this group by and duplicates? Okay, so I'll give you just one link each. It will just be one page or so for each one of them. You read up those two things and I'll give some questions on the same Tokyo Olympics data, sorry, on the 120 years of Olympic history, same data set. So no change in data set. On the same data set, you can go ahead and I'll give you some questions that involve duplicates, some questions that involve missing values and how to reap averages and things like that, and something to do with group bys. So homeworks with averages, missing values, duplicates, group bys. Okay, so unless you have any other questions, thanks a lot for attending today's session. Hope you guys have a good weekend. Someone was showing me some code right earlier, which had some.
Yeah, that was me.
Right. Can you share screen? Let's see what was the error. Right.
We were looking at the youngest. I mean, we were looking at the oldest one, but I did the youngest one as well, and
And you're still
I
getting
got
some.
different. Yeah, so I think there's something wrong
Right.
with this sort function or something.
Right. So let's see what is going on first of all. Okay. Can you scroll up a little bit?
Wait,
Where? Yeah, there. Right. Okay. So file athletes of age. Okay. So that gives you athlete age. File athletes of name, that give you athlete names. Okay. So age of athletes dot append. So just take the first, starting from that age of athletes array till the loop, the first for loop, take that whole thing into another cell, including that first for loop, including that first for loop, take that into another cell.
What do you do first?
You can click code there. Yeah. And after the loop is done, say min of age of athletes. Okay, you're getting it as 10. Let me check on my side. So min is 10. So min is doing a good job. So that means your array has right data. Now, if you do sort age of athletes dot sort. Now do age of athletes of 0 or print age of athletes of 0. No square bracket. Interesting. So why is sort behaving sortless in such random thing? Wait a second. Can you try one small thing, like when you do that age of athletes dot append of count, yeah, there, do float of count or int of count. Yeah. Instead of append of count, you just do int of count. Oh, I see. Yeah. Okay. Now I think okay. Run this. Let's see. It should give you an error. Yeah. So what's happening is nans are coming and disturbing the whole thing basically. When NaN is present, when you're appending that value to your array, that NaN is kind of becoming a string. So it's converting your array or some parts of your array to look like strings, others to look like floats, and sort is doing a poor job in that situation. So you should almost say if, before that you should say if count not equal to np.nan, and you have to probably import numpy as np. I think it's nan lowercase, all lowercase. And then put that append inside that if instead of in that. Now let's see. Still.
So remove the int.
No, but our problem is not int or not int, right? Like it's the fact that this NaN is getting converted to int. That's why it's not working. So maybe say count not equal to NaN also instead of np.nan not equal to NaN with that capital as a string. Do it as a string.
Okay.
Like that. I don't know what's the comparison here, but cannot convert NaN to integer. Oh, no. You can say if np dot is null, I think np dot is nan. No. If np dot, no, you don't need the count not equal to anymore. If, yeah, you can remove that. If np dot is nan of,
Okay.
no, off in the sense parenthesis, sorry,
Okay.
count. And then you put like a not symbol before the if np dot that. So not. Yeah, now run this. Let's see. So that doesn't look like that's right. Oh, this returns just for the whole array. 1 second. I think there is no space in between not and NP. That's all it's complaining about. No? Okay. Not is not equal to true. Instead of saying not before, you can say not equal to true.
Oh, nice.
Oh, it finally, yeah. So main thing that was going wrong is because you added NaNs into lists, and the list is not smart enough to recognize that there is an NaN.
Yeah. Okay.
Same thing for pretty much all of your for loop based solutions, but please avoid for loop based solutions as much as possible, or loop based solutions in general.
Okay.
Yeah, I know it looks like you're very familiar with Python coding in general based on the speed with which you're typing, at least. I know it is hard to get out of that habit, but there is a huge cost difference between doing something with a loop versus without a loop. Okay, cool.
Okay. Thank you.
Thank you.
Bye.
Okay, bye. Okay. Bye, Pawan. Bye, Balaji. Bye, Ashok.
Thank you, Karthik. Thank you.
Bye. Thank you.
Yeah. Thank you.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrico.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!